Hi everyone, this is Xuejian here. Through this short video, I will present my design project for electrical circuit. My task is to design an evacuation lightning system using breadboard along with electrical components or an electrical simulation software. To specify, the circuit have to include backup voltage supply and to ensure the current running through two parallel circuit elements such as resistors. We need one safety sign and an evacuation sign to be inserted into each of the circuit elements respectively, so that during the urgent cases, the safety sign will become darker with the evacuation sign becoming brighter. This aims to let the crowd know where to evacuate within 10 seconds. After a long period of time, we need the two signs to stay at relatively stable brightness. And to design our circuit, we will prototype and analyze using the SimScape models in MATLAB. A circuit will be constructed using the electrical library, and the performance of the system will be examined through the simulation in Simulink. Our simulation time starts from 0 to 10 seconds, and the variable step and the automatic solver is selected. After that, we determine the appropriate location for each signal in the circuit so that they can operate properly as stated above. We first need to construct an operational amplifier, which aims to enlarge the input voltage and supply it to the whole system. I select the following electrical elements for the op-amp. I have two 10-ohm resistor, two 100-ohm resistor, one 20-volt DC voltage, one 100-volt DC voltage source, and one ideal op-amp. We have two input sources, so it ensures the system continues supplying output even if any of the voltage supply breaks down. I pick resistor and capacitor setup to complete the remaining of the task. I have two 20-ohm resistors and 1.05 farad capacitor, and I let one resistor and the capacitor be in parallel while the other resistor is in series with them. The current sensors and the voltage sensors are needed to present relevant data. So later on, we will determine if the safety sign or the evacuation sign will be inserted in any of these two parallel circuits. For the circuit calculation and analysis, let's go through the operational amplifier first. So I do the following calculation to come up with the output voltage. In specific, I apply the KCL equation at the top node, which is right here, and the other KCL equation at the bottom node, which is right here. And solving the two variable linear equation using the matrix, we have the result of 800 volt. And apparently the output voltage will not be zero even if one of the input voltage is taken out. And this satisfies our pre-requirement for the task. We will check this out through a voltage sensor during the simulation. For the current running through the parallel capacitor and resistor, I also assigned a voltage called VA at the node in this position, and also apply KCL at the top node. So we get a first order differential equation, 0.5 dVA over dt plus VA equals 400, and we have the initial condition VA time equals 0 is 0. And we use MATLAB to solve, come up with VAT equals 400 minus 400 times e to the power of minus 2t. Applying Ohm's law, we get the following equations for the current through the resistor and capacitors, this order. Based on the calculation above, I use the graphing calculator to plot the trend of IR and IC, which is right here. Uh, so the graph of IC is declining while the graph of IR is increasing with the time growing, and they become relatively stable after a long period of time. We will check this out during the simulation as well. So we can now go back to our SimScape page. We first will simulate the op-amp behavior. Uh, we have all the voltage supply and resistors setting up, and we can run the simulation now. Okay, so it shows 800 volt, which is corresponding to our previous calculation. And we can now take out this voltage supply and comment this out, run it back. So it is 1,000 volt for the output voltage. So which satisfy our pre-requirement that any of the voltage taken out, we will have an output voltage to make sure the whole system will operate their functions properly. So now we can plug this back in. And reconnect the whole system. So we can now run the entire simulation now. Okay, double click the scope. Yeah, so we observed the same trend of the current running through the capacitor and the resistor like we mentioned before. And we come up with a conclusion that the safety signal will be in series with the capacitor because the capacitor branch is experiencing a decrease in current running through it, so the safety signal will be becoming darker, and the evacuation sign has to be in series with the resistor because the resistor current is increasing, and the evacuation sign will of course become lighter and brighter.